to solve maximum depth of binary tree. This problem is listed under LeetCode 75. Let's read the description. So given a root of binary tree, return its maximum depth. So the problem here needs the maximum depth from the root node to the farthest leaf node. And what leaf node means that a leaf node doesn't have a child. So I'm gonna explain how the solution is gonna work. All right, so let's start from here, the node that has value 3, which is the root node. So I need to find the maximum depth. So obviously we have two solutions. All right, the first one is 3, 20, 15, and 327. So what I'm gonna do is to compare between the left subtree and the right subtree. So I need to compare for every node the left subtree and the right subtree depth. So I'm gonna start from 3, then I'm gonna go to 9. And since 9 is at the leaf node, I'm gonna increment the depth with every time I call the function. So node 9, which has value 9, will return 2 since it's a leaf node. Then I'm gonna go to the right node. It's gonna go 3, 20, and 15. 15 will return 3. Then I will go back to 20, and then from here I'm gonna call 7. Then it's gonna pop out of the stack. Then I'm gonna compare the two nodes which has the maximum value, which will be 3, since both has depth of 3. Then this call function will be popped from the stack, and then I'll be here. I'll be having to compare between 2 and 3, and then the maximum value between them is 3. So let's go and implement this solution. I'm gonna define a function called helper inside maximum depth. And also I need to add the depth with every call I call the helper function. I have to make my condition in a recursive function. If the root is none, then return the depth. So here, this statement is gonna be called for two situations. The first situation that I don't have any node. So let's say one of the test cases is there is no root, and the number, and if we read the constraints here, the number of nodes in the tree is in the range from 0 to 10 power 4. And the second situation, when we reached to the leaf node, then I'm gonna need to make a call to the left subtree. I'm gonna pass the left of the node, then I'm gonna increment the depth by 1. Also I'll do the same for the right. Helper root right, depth plus 1. Then I'm gonna need to return the maximum between them. So we finished the solution. We just only need to call the helper function from the maximum depth and return the result. and the depth initially will be 0. Let's try to run it. So the solution passed all the test cases. If you have any questions, just leave a comment under the video. Thank you.